Good afternoon to everyone. I am Bhuvaneswari, Assistant Professor of Physics, Sita Lakshmi Ramaswamy College, Trishurapalli from Tamil Nadu. And I am going to discuss about the concept of Polaroids and the principle behind that and few of its applications. So first let us start with the understanding of the Polaroids. So the Polaroid is a device that filters the light waves, allowing only certain orientations of light to pass through it. So they have the special ability to cut the glare of the light reflected from water or glass. The light that passes through it is called the polarized light. Now, these Polaroids are nothing but polarizing filters, commonly known as polarizing sheets. They are called as the Polaroids. These sheets contain the long chain molecules that are aligned to allow electric field oscillations along only one direction. So a polarizing filter produces the polarized light from unpolarized light by selectively allowing electric fields along a single plane. That plane is called plane of polarizations. Polaroids have this ability because of using the wave characteristics of the light, not the particle nature. Now let us discuss about the functions of a Polaroid. Polaroid is a physical device. It's used to filter the light rays. It consists of the systematic arrangement of lenses, and the light rays when passes through these Polaroids, only half of the total rays pass through it and the remaining half get reflected into the surrounding area. The Polaroids are manufactured artificially by the suitable arrangement of the lenses. Now coming to the uses of the Polaroids. Polaroids is used to enhance the experience of three-dimensional movies and pictures. Polaroids is used as a filter in cameras, that is especially in the cameras of the mobile phones. It's also used in liquid crystal displays. They are used in calculators, monitors, watches, which contains liquid crystal display screens. Polaroids are even used in the windows of the aeroplane to reduce the intensity of the sunlight entering into the aircraft. Now we are all very familiar with Polaroid sunglasses. Now let us focus on the functions of the Polaroid sunglasses. So the light from the sun gets scattered in all directions. The surface of the earth is very small compared to the surface of the sun. So the amount of energy, light energy coming from the sun is very much higher than the total surface area. So the large amount of light is getting reflected at any instant on the earth surface. So these Polaroids are used in sunglasses to restrict the entry of the glare reflected sunlight and protect our eyes. Now these two photographs are you seeing, no, this shows the effect of the polarizing filter in reducing the glare in sunlight reflected from the surface of the water. The second picture B was taken with the polarizing filter and the first one was not. So as a result, the reflection of the clouds and sky was observed in the first one and it's not observed in the second one, which was used by the polarizing filters. So polarizing sunglasses are particularly useful on snow and water surfaces. So these Polaroids are used in spectacles to reduce the glare. They are also used in night driving goggles as they can filter out the partially polarized light reflected off windshields. Now, coming to the concept behind this Polaroids or polarization. Polarization is a phenomenon that is caused by the wave nature of the electromagnetic radiation. So, polarization is the attribute that a wave oscillations will have a definite direction. They have a selected orientation related to the direction of the propagation of the wave. So, these polarized waves have directions inclined on a single plane. Such waves are called plane polarized wave. And this phenomenon of the waves having such a direction are said to be the polarized. Now, coming to this electromagnetic wave spectrum, the electric and magnetic vibrations of a light wave occur perpendicularly to each other. Now, this figure shows the light, which is a type of electromagnetic wave, is having the interaction of electric and magnetic field traveling through space. So for an EM wave, we define the direction of polarization to be the direction parallel to the electric field. Now, as I already told you, the electric and magnetic vibrations of the light wave occur perpendicularly to each other. So we have one plane that was occupied by the electric field and the other plane that was occupied by the magnetic field perpendicular to it, and the direction of the travel is perpendicular to the both. So now we can think of this electric field arrows as showing the direction of the polarization. The light wave that is vibrating in more than one plane is known as the unpolarized light. We all know that light is a type of electromagnetic wave. These electromagnetic waves are transverse in nature and consisting of varying electric and magnetic field that oscillates perpendicular to the direction of the propagation of the wave. And we'll concentrate the electric field vector only. So the light wave, the figure shows in this light wave, the electric field vector vibrates in all around the 360 degree. So it vibrating more than one plane. So this light that is emitted by the sun or by even a lamp or a tube light are all called unpolarized light source because they are having the electrical vibrations in more than one plane. So they are called as the unpolarized light. Now coming to the deep of the concept of the polarization, in the above image, you can see that a plane polarized light vibrates on only one plane. So the light from the unpolarized source is allowed to fall over the polarizer. So this unpolarized light is having the electrical and magnetic vibrations, and after falling through this, moving through this polarizer, the output light, that is a plane polarized light, contains the vibrations in only one single plane. So these polarized waves are the light waves in which the vibrations occur in a one single plane. So these plane polarized light consists of waves in which the direction of the vibration is same for all the waves. So this process of transforming the unpolarized light into the polarized light is known as the polarization. Now, Polaroid materials invented by the founder Polaroid Corporation, Edwin Land, act as a polarizing slit for a light, and it allows only polarization in only one direction to pass through it. So these polarizing filters are actually composed of long molecules aligned in one direction. Thinking of these molecules as many slits analogous to those for oscillating ropes, we can understand why the light with a specific polarization can get into it. So the axis of the polarizing filter is nothing but the direction along which the filter passes the electric field of the unpolarized EM wave. Now this figure shows the effect of two polarizing filters on the incoming unpolarized light. The first filter polarizes the light along its axis. When the axis of the first and second filters are aligned parallel to each other, then all the polarized light passes through the first filter is also passed by the second filter. Now we can see the output light. But if the second polarizing filter is rotated, only the component of light parallel to the second filter's axis is passed. When the axis of the second filter is perpendicular to the first one, no light is actually passed by the second. So only the component of EM wave parallel to the axis of the filter is only passed, as discussed in the earlier slide. Let the angle between the direction of the polarization and the axis of the filter is theta. If the electric field of the incident wave has an amplitude E, then the transmitted wave has an amplitude of E cos theta. And the intensity of the since the intensity of the wave is proportional to its amplitude squared, and the intensity I of the transmitted wave is followed by the given relation as per law of Morse. Coming to the applications of polarization, polarization plays a significant role in various fields like optics, telecommunications. We are all familiar with polarized glasses. Viewers wear glasses with matching Polaroid filters, allowing each eye to see only the corresponding image, creating a stereoscopic effect. And in 3D movies also, polarized filter creates separate images for each eye, allowing the 3D effects. Some theaters use circular polarization, which allows the audience to tilt their heads without losing the 3D effect. And polarized light helps to reveal the details of biological specimens also. And using this polarizing filter, the photographs of the sky can be darkened, a trick used by many photographers. And detecting the polarization of scattered EM wave can be useful in analytical tool in determining the scattering source. And there is a range of optical effects used in sunglasses. Besides being the Polaroid, other sunglasses have colored pigments embedded in them, while others use non-reflective or even reflective coatings. Polarized light helps detect stress in transparent materials, including glass and polymers. Strain pattern appears as color variations when viewed under crossed Polaroid filters. These Polaroid lenses block the glare by filtering out horizontally polarized light. And polarized lenses contain a polarizing filter that blocks this polarized light while allowing vertical light to pass through it. This reduces the glare, enhances the contrast, and improves visual clarity. And Polaroids are used in 3D imaging and movies through polarized light technology, which enables stereoscopic vision. And Polaroid provides comfort for people sensitive to bright light or reflections. Polaroids cuts glare from the water surfaces, allowing better visibility of the objects beneath the water surface. Lights are used in microscopy, primarily for polarization microscopy, which is useful in studying the bright fringe materials, stress patterns in transparent specimens, and certain biological and geological samples. Also, in unstained biological specimens, polarization helps improve contrast without the need for dyes. So finally, I conclude the Polaroids, based on the principle of polarization, have significantly contributed to various fields, including optics, imaging, and vision enhancement. Their ability to filter specific light waves makes them essential in sunglasses, photography, 3D imaging, and stress analysis. Future development involve are smart and adaptive polarized lenses, advanced 3D display, and medical and scientific imaging, augmented reality, and virtual reality. Thanks for watching the video. Thanks to all.